Hi everybody, today we're going to be talking about lesson 66, prime factorization. This is part 2, using a factor tree. So in part 1, we talked about prime factorization, finding all of the primes that I can multiply together to get a specific number, and we used division of primes. Today we're going to work from kind of the top down and do something similar, but today we're going to use a factor tree. So we're going to start with an example before we actually jump into example 2. So let's find the prime factorization of the number 12. We already know that 12 equals 2 times 2 times 3. So how do we get that? Well, we have several ways. So first I'm going to write the number 12 at the top, and this time I'm going to work my way down. And I'm going to write one way that I can multiply two numbers together to get 12. Okay, other than using 1 times 12, other factors. So I'm going to use 3 times 4. Now I'm going to look at each of these numbers and I'm going to ask myself, is it prime? Since 3 is prime, I'm going to go ahead and circle it because I'm going to stop there. I'm not going to try and factor this further. It has no other factors other than itself. 4, however, I can keep going. 4 is composite. So I'm going to draw 2 more little diagonal lines, and I'm going to ask myself, what can I multiply together to get 4? And I know that 2 times 2 equals 4. Well, 2 is prime, and 2 is prime, so I'm going to stop here. I have nothing further that I can factor out because these are all prime. So now if you take a look here, I've circled a 2, I've circled a 2, and I've circled a 3. So I'm going to take these circled numbers and write them just like this and show my prime factorization. Okay, let's look at another one. So let's look at example 2. Use the factor tree to find the prime factorization of 42. So I'm going to write 42 here at the top and put my little upside down V here and ask myself, what can I multiply together to get 42? Well, I know 6 times 7 equals 42. 6 is composite. I have to keep going there, but 7 is prime. So I'm going to go ahead and circle this to show that I stop there. I don't factor any further. 6, however, because it's composite, I'm going to keep going. 6 I know I can make by multiplying 2 times 3. I know that 2 is prime and 3 is prime, so now I'm finished. So 42 equals 2 times 3 times 7. Notice I'm writing these in order from least to greatest, and I am rewriting them showing my prime factorization. This right here is not an answer. Rewriting it this way, this is a complete answer. All right, let's do another couple just so we can get these kind of under our belts. Okay, let's do 36. All right, I know that one way to get 36 is to multiply 4 times 9. Okay, well 4 isn't prime, so I'm going to keep going over here. I can get 4 by multiplying 2 times 2. This is prime. Both of these are prime. Now, 9, I can multiply 3 times 3. 3 is prime and 3 is prime. So 36 equals 2 times 2 times 3 times 3. If I took all 4 of these circled primes and multiplied them together, I would equal 36. So this is my prime factorization. Okay? All right, let's do one more. Let's see. Let's take the prime factorization of, let's do 40. No, I don't like 40. Let's do 32. 32. I like that one. Okay, I can multiply 32 in two ways. So we're actually going to do this twice. Move this over. All right, so I know that 4 times 8 is 32. Neither 4 nor 8 are prime. So 2 times 2, those are both prime, so I stop there. 8, I multiply 2 times 4. 2 is prime, 4 is not. It's composite, so I keep going. 2 times 2. So 32 equals 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Multiply all these together, and I'm going to equal 32. However, I also know that 32 equals 2 times 16. Well, here's prime here, but 16 isn't. So I'm going to factor this one out. 16 equals, I can either say 2 times 8 or 4 times 4. It doesn't matter. I'm going to go with 4 times 4. Neither of these, whoa, excuse me, 4 is not prime. Neither of these are prime. They are both composite. So we're going to keep going. 2 times 2. Now these 2's are prime. And this 4 is also 2 times 2. So again, I have 2 times 2 times 2 times 2 times 2. So notice, it doesn't matter if I start with 4 times 8 or 2 times 16. I still end up with the same prime factorization. So there are multiple ways to get to the same answer. Okay? All right, that's it for prime factorization using a factor tree. Make sure you've watched both part 1 and part 2 of this lesson before proceeding to your lesson practice, and I will see you in the morning.